If you want to go really deep and really understand how requests and responses work on the web, then this video is for you. So this is basically a high-level overview of how the web actually works behind the scenes in regard to requests and responses. Now, this knowledge is not required though for moving on in the course, and that's why I marked this video as optional. So you can safely skip it if you want to move on more quickly, but if you're interested, then just keep watching. So this is the diagram that we already saw when we first talked about AJAX calls. So just to recap, whenever we try to access a web server, the browser, which is the client, sends a request to the server, and the server will then send back a response. And that response contains the data or the web page that we requested. And that's right, this process works the exact same way, no matter if we're accessing an entire web page or just some data from a web API. And this whole process actually has a name, and it's called the request-response model, or also the client-server architecture. But anyway, let's now dive a bit deeper into this. So let's use the example of the URL that we actually accessed in the last video to get our country data. Now, every URL gets an HTTP or HTTPS, which is for the protocol that will be used on this connection. And we're going to talk about this a bit later in the video. Then we have the domain name, which is restcountries.eu in this case. And also, after a slash, we have the so-called resource that we want to access. And in this case, that's /rest/v2, and so on. Now, this domain name restcountries.eu is actually not the real address of the server that we're trying to access. It's really just a nice name that is easy for us to memorize. But what this means is that we need a way of kind of converting the domain name to the real address of the server. And that happens through a so-called DNS. So DNS stands for Domain Name Server, and domain name servers are a special kind of server. So they are basically like the phone books of the internet. So the first step that happens when we access any web server is that the browser makes a request to a DNS, and this special server will then simply match the web address of the URL to the server's real IP address. All right? And actually, this all happens through your internet service provider, but the complete details don't really matter here. What you need to retain from this first part is that the domain is not the real address, and that a DNS will convert the domain to the real IP address. And then, after the real IP address has been sent back to the browser, we can finally call it. So this is how the real address looks like. So it still has the protocol, but then comes the IP address and also the port that we access on the server. And this port number is really just to identify a specific service that's running on a server. So you can think of it like a sub-address. Okay. This port number has nothing to do with the /rest/v2 resource that we want to access. So that resource will actually be sent over in the HTTP request, as we will see in a moment. Okay, and that actually wraps up the first step. So once we have the real IP address, a TCP socket connection is established between the browser and the server. And so they are now finally connected. And this connection is typically kept alive for the entire time that it takes to transfer all files of the website or all data. Now, what are TCP and IP? Well, TCP is the Transmission Control Protocol, and IP is the Internet Protocol. And together, they are communication protocols that define exactly how data travels across the web. They are basically the internet's fundamental control system, because, again, they are the ones who set the rules about how data moves on the internet. And don't worry if that sounds confusing, we are actually going to learn a bit more about TCP/IP a bit later in this video. But anyway, now it's time to finally make our request. And the request that we make is an HTTP request, where HTTP stands for Hypertext Transfer Protocol. So after TCP/IP, HTTP is another communication protocol. And by the way, a communication protocol is simply a system of rules that allows two or more parties to communicate. Now, in the case of HTTP, it's just a protocol that allows clients and web servers to communicate. And that works by sending request and response messages from client to server and back. Now, a request message will look something like this. The beginning of the message is the most important part, called the start line, and this one contains the HTTP method that is used in the request, then the request target, and the HTTP version. So about the HTTP methods, there are many available, but the most important ones are GET for simply requesting data, POST for sending data, and PUT and PATCH to basically modify data. So you see that an HTTP request to a server is not only for getting data, but we can also send data. All right. Now about the request target, this is where the server is told that we want to access the REST/v2/alpha resource in this case. Remember that? So we had this in the URL before, and now it is simply sent as the target in the HTTP request. And so then the server can figure out what to do with it. Now, if this target was empty, so if it was just a slash, basically, then we would be accessing the website's root, which is just restcountries.eu in this example. Then the next part of the request are the request headers, which is just some information that we sent about the request itself. There are tons of standard different headers, like what browser is used to make the request, at what time, the user's language, and many, many more. Now finally, in the case we're sending data to the server, there will also be a request body. And that body will contain the data that we're sending, for example, coming from an HTML form. So that is the HTTP request, and I hope that it makes sense to you. Now, of course, it's not us developers who manually write these HTTP requests, but it's still helpful and valuable that you understand what an HTTP request and also a response look like. Also, I want to mention that there's also HTTPS, as you probably know. And the main difference between HTTP and HTTPS is that HTTPS is encrypted using TLS or SSL, which are yet some more protocols, but I'm not going to bore you with these. But besides that, the logic behind HTTP requests and responses still applies to HTTPS. All right, so our request is formed, and now it hits the server, which will then be working on it until it has our data or web page ready to send back. And once it's ready, it will send it back using, as you can guess, an HTTP response. And the HTTP response message actually looks quite similar to the request. So also with a start line, headers, and a body. Now in this case, the start line has, besides the version, also a status code and a message. And these are used to let the client know whether the request has been successful or failed. For example, 200 means OK. And the status code that everyone knows is 404, which means page not found. So that is where this 404 code that everyone already knew comes from. Okay? Then the response headers are information about the response itself. So just like before, and there are a ton available, and we can also make up our own, actually. And finally, the last part of the response is, again, the body, which is present in most responses. And this body usually contains the JSON data coming back from an API or the HTML of the web page that we requested, or something like that. So we talked in great detail about the most important parts here, which are the HTTP request and the response. But in our imaginary example, we only just did one request to restcountries.eu and got one response back, right? And that's how it's going to work when all we do is to access an API. However, if it's a web page that we're accessing, then there will be many more requests and responses. And that's because when we do the first request, all we get back is just the initial HTML file. That HTML file will then get scanned by the browser for all the assets that it needs in order to build the entire web page, like JavaScript, CSS files, image files, or other assets. And then for each different file, there will be a new HTTP request made to the server. So basically, this entire back and forth between client and server happens for every single file that is included in the web page. However, there can be multiple requests and responses happening at the same time. But the amount is still limited because otherwise the connection would start to slow down. But anyway, when all the files have finally arrived, then the web page can be rendered in the browser according to the HTML, CSS, and JavaScript specifications that you already know. Now, as a final piece of the puzzle, let's talk again about TCP/IP and figure out how this request and response data is actually sent across the web. Okay? So we said before that TCP and IP are the communication protocols that define how data travels across the web. Now, I'm not going to go into a lot of detail here, but here is what you need to know. So first, the job of TCP is to break the requests and responses down into thousands of small chunks called packets before they are sent. Once these small packets arrive at their final destination, TCP will reassemble all the packets into the original request or response. And this is necessary so that each packet can take a different route through the internet. Because this way, the message arrives at the destination as quick as possible, which would not be possible if we sent the entire data simply as a big chunk. So that would be like trying to go through dense traffic with like the biggest bus that you can imagine. So probably not a good idea. Now, as a second part, the job of the IP protocol is to actually send and route these packets through the internet. So it ensures that they arrive at the destination they should go using IP addresses on each packet. Okay, and that's it. That's a broad overview of what really happens behind the scenes of the web. And I hope that you found this information useful and also interesting and not all too confusing. But anyway, now let's go back to our JavaScript and AJAX calls.